Hi, everybody. My name is Jeff Bush, and I'm an engineering manager on the Android Auto team. So great to see so many people here. I hope people didn't get too sunburned today. So we're going to talk about a few things in today's session. First, I'm going to spend a few minutes talking about where we are today and what we're working on. Then a few of my colleagues are going to come up and do some short demos. But the majority of this session is going to be a deep dive into how to bring your apps to Android Auto. In 2014, we launched Android Auto with our partners in the Open Automotive Alliance to create a platform for connected services in the car. In the 2 years since, we've gained a lot of momentum. We now have 40 manufacturers signed up to support Android Auto, and there are over 100 models of cars on the road today that use Android Auto. By the end of the year, we're expecting to double this number to 200 and support every major car manufacturer. And developers are flocking to the platform. We currently have hundreds of apps available, and more are coming every day. So I wanted to take a minute to say thank you to all the developers who've supported Android Auto. We've also recently launched Android Auto in 19 new countries, including Brazil, Russia, and India, which brings us to 30 countries, and more are on the way. We're really excited about how far the platform has come, and we're even more excited about the future. We've gotten a lot of great feedback from our users, and I'm pleased to say that the 3 most requested features are coming soon. The first is OK Google. Android Auto already supports a rich voice interface, but being able to initiate commands hands-free is a natural for the car. So we're bringing OK Google hot wording to Android Auto. The second is Waze. As someone who commutes every day in Silicon Valley, I'm pretty excited about this. Waze has an active community of millions of users sharing real-time traffic and accident information to save time on the commute. And Wazers have been very vocal about Android Auto support. So we've been working with Waze to make that happen. I think they've done an awesome job, and you can actually see it in action in our demo cars in the sandbox right over that way. The third is wireless. We think Android Auto is a great experience, but wouldn't it be even better if you could use it without even having to take your phone out of your pocket? So the good news is that we're working with our manufacturing partners to bring support for wireless to their Wi-Fi-enabled cars. So these are 3 new exciting new features. There are many other smaller improvements that we're working on, but we can't ignore the fact that there are over 1 billion drivers on the road who don't yet have cars that support Android Auto. We know that many drivers are already using Android phones in their car dock for turn-by-turn navigation and media streaming. We think we can make that experience easier and safer by letting people use Android Auto on their phone screen while docked. So, coming soon, Android Auto will give access to the same features, voice-enabled media, messaging, and navigation right on the phone screen using an interface that's designed for driving. Paco will be up on stage to tell us more about it in a few minutes. We also have this running in our sandbox, and I'd recommend checking that out as well. This opens up Android Auto to a huge number of new users, and that's a great thing for developers too. So we're excited about bringing Android Auto to old cars and new. But what about the future? A trend that we're seeing is cars with larger screens, fully digital instrument clusters, and cellular connectivity. But to get the innovation we've seen on the web and smartphones, we need a platform, and more importantly, we need an ecosystem. In fact, many manufacturers have recognized this and are already choosing Android Auto for their IVI operating system. But they have to do a lot of work to adapt it to an in-cabin experience. So we're putting automotive support into mainline Android to make a great platform for built-in infotainment. This includes support for vehicle networks, HVAC, and an infotainment user interface and built-in apps. Being built on Android, it supports everything that makes Android great, like multi-user and multitasking. And it'll be completely free and open source, part of the Android open source project. In fact, in the Android N release coming later this year, we'll include many of these features already. We're really excited to work with our car manufacturing partners to bring Android to their future cars. And in our sandbox, we have a concept car that we've built with Qualcomm showing off this technology. That's one I would definitely recommend you check out, although there's a bit of a line right now. But most importantly, we're working to ensure that apps built for Android Auto work seamlessly on our built-in infotainment systems. So there's a lot of cool stuff in the works. And with that, I'd like to hand over to Paco, Vincent, and Victor to show you some of the demos of some of the things I've talked about.
Thank you, Jeff. Thank you. It's good to see so many of you here today. It helps that it's air-conditioned in here. It's pretty hot out. So I'm Paco Galanes, and I'm an engineering lead with Android Auto. As Jeff mentioned before, we are expanding the Android Auto platform to create new experiences for existing drivers. by expanding the Android platform into the car, and by bringing the experience that we've shown you in the car directly into the phone screen. We are also expanding Android directly, natively into the car, and that is the concept car that Jeff already announced. I'm going to now give you a demo of how this all works together and show some of the features that Jeff announced. All right. So we have Vincent here, and he is showing the desktop head unit. This is a tool that all developers have available, and it emulates how the car screen works once you plug your phone in. All right. So once you plug in, you launch into the home screen, and that gives you access to tasks that you may perform right to get started. We have suggested destinations. We know where you are, your location, your time of day. So we can tell you, you may want to start navigating to work today. And all this, of course, uses the same Google Smarts that we use all throughout the platform. For those of you not familiar with the platform already, let's do a quick walkthrough. So the activity bar at the bottom of the screen gives you access to common applications that you'll be using while driving. We have media. Of course, you have access to your dialer and your common contacts. That wasn't it. Contacts, dialer, there it is. And of course, you have also access to navigation and maps. All right, perfect. Let's go back to the home. Notice that the whole screen is a lot bigger than any other application that runs on your phone. And this is because it's designed for driving. You need to tap that screen while it's running at arm's length on your dashboard. All right. Let's go into navigation now. Of course, we have integrated Google Maps with all the great navigation tools that you're all familiar with. But Android is a platform. We're working on also integrating Waze, as Jeff announced, which is a tremendously popular navigation app, as you all are aware. Let's switch to it. There it is. All right. Woo! Vincent is going to pick directions. We're going to the beach later today, so he's getting a head start. He has the directions right there in his favorites, and off he goes. Great. As with Google Maps, the same applies here. We display the next turn right there in this interface, but you also recognize some of the Waze-specific features in the screen, like reporting an incident. It's right there. Great. We've also integrated messaging, by the way, though it's mostly a voice-driven experience. And speaking of voice, of course, we've enabled most of the common tasks that you can perform while in the platform, while using Android Auto via voice. All right, let me show you how messaging actually works in the platform. I'm going to text him, telling him that I'll meet him later. Of course, he gets a quick notification. Messaging is a notification-driven application. In the alert, we show you enough information to know if you really need to take it or not. But it goes away, and it's always available through the home screen. He can decide to listen to the message when it's safe to do so. Right?
Here's the message. Finishing my presentation at Google I/O. Let me know when you get there.
Now, he could use voice to send me a quick message, or we always give you a pre-canned, customizable message that you can just tap and let me know that, I'm driving now, don't disturb me. Note that this works with many messaging works, not only SMS. We have many applications that are already integrated. Chances are that your favorite application is already in the platform. If you haven't integrated your app yet, we'll show you later how to do so. Thank you, Vincent. Let's switch to the video down below. And let's see what Victor has for us there. All right. So that is a testing harness for the concept car that we have out there in the sandbox, the Maserati. Come see it later if you get a chance. The concept has two screens, both powered by Android. The instrument cluster, right above the steering wheel, of course. And the bigger infotainment system to the right. Very good. Because of the larger screen that we have available here in the instrument, in the infotainment screen, we can make use of the multi-window features of Android N to display more than one application at the same time. You'll notice at the bottom, we have the climate control application. It gets hotter today, so let's cool it down. In the middle, we have the currently rain application, right now, navigation and maps. He's already going to meet us later. And at the top, we have a permanent screen where we can show you other running applications, other running activities, and we can also, of course, show you some content coming from, from Google Now or other notifications from the system. All right, let's focus on the cluster for a minute. Very traditional looking cluster with a fuel gauge, speedometer, and something new there, which is the next turn from Google Maps. That area can also be used for other notifications, like in this case, the next track from the media player. Let's move back to the big screen, please. All right. Now here we see how Victor switched to the media player as the main application. And notice that, I don't know if you noticed that, the navigation card went on top to the notification area, to the permanent area, right there. Perfect, thank you. For the media section, he has access to all the Android auto-enabled applications, media applications that are already out there. Whatever is in his car, he'll pick one. Great. Media applications have two main screens. We saw the first one with the playback controls. Those playback controls are standard: play, pause, skip. Some of them are customizable. And of course, we have a second screen, which is showing now, which is the menu for browsing content, where applications show what's available for the user to pick. We recommend that we keep the hierarchies kind of shallow, and that we try to surface on top personalized content, frequents, favorites, etc. So it's less distracting. All right. I hope you can hear that.
This can help anyone get really good at just about anything.
I thought he was going to play salsa, but he's on a podcast today. All right. Victor will talk to you later about how to integrate the media applications into the platform, if you haven't done so already. Thank you, Victor. Let's move to the phone area here. Great. Let me show you how the third Android surface will work. It's Android Auto on the phone screen. No new car needed. All I have to do is bring up the Android Auto application from the icon. And here I am in the Android Auto home screen, adapted to the screen in my phone. This should look very familiar to you already. I can also set Android Auto to auto launch when it detects the Bluetooth device in my phone when I turn it on, for instance. From the home screen, I have access to the same suggested destinations we talked about before. Android Auto is the same platform. I also have ongoing activities like media. And it can show me missed messages or missed calls that I may want to return. All right, so from the media card, I can always go to the media app. Again, I have access to all the media applications that are running on my phone that are Android Auto enabled. Books, podcast, several music apps. Let me pick one. And when we launch the app, I can start playing where I left off.
To show Avicii I was cool. And when I finally got sober, felt 10 years.
But I also have access to the full menu, just one swipe away. By the way, the customizable controls are also here. All right. Another thing that I wanted to show you quickly is how messaging works in this screen. So Vincent is going to tell me when he's up here that he's already in Santa Cruz waiting for me. It's taking him a little long to get there today. All right. So here's the message. Notice that the notifications in the phone screen are a little larger than usual. They're adapted for the smaller screen size, so I can tap them while I'm driving. As we saw before, I don't have to tap that notification to listen to it. It's always in my home screen.
Here's the message. Hey, I'm here now. You can press the voice button and say, reply.
Of course, I could try to reply with voice, but as always, the auto reply message is there, and I can just tell him, hey, I'm driving right now. I'll catch you later. All right. The last thing I wanted to show you is how the power of voice integration works with Android Auto. I don't know if this will work in the environment. You guys are kind of quiet, so I'm going to try. Let me see. Navigate to Santa Cruz.
Santa Cruz, USA? All right. You should reach your destination by 7:32 p.m.
Great. So I'm navigating. And of course, the next turn is always available from the home screen, so I don't miss a turn, no matter what I'm doing.
Turn right onto Bill Graham Parkway.
Let me stop this for a second. All right. So I hope that this quick demo gave you an idea of how the platform works together. Next thing that we're going to do is, let's go back to the slides. Perfect. We're going to go into more detail about how you integrate your apps into the Android Auto platform. We're going to talk about messaging, and we're going to talk about media. And remember that if you already integrated your app, it'll run seamlessly on both phone and car screens. We use the same interfaces across all three surfaces. If you haven't integrated yet, stay around. And Victor is going to tell us how to integrate with media.
Cool. Thanks, Paco. Okay. Hi. Hi, I'm Victor. I'm a software engineer on the Android Auto team, and I'm here to talk about media apps. There are a couple of things I want to focus on today. First of all, we'll look at how to make your media app compatible with Android Auto. Then I'll offer some tips and best practices to help you provide a great media experience inside of a vehicle. So as you saw earlier in the demo, media content can show up in many different forms in various Android Auto devices. On the left here, we have our media facet, which is a templated UI experience where the user can control playback, and also we offer browsing capabilities. On the other hand, media content can appear more passively, such as a card inside of our overview stream, or as a notification inside of our instrument cluster. And I just want to point out again, across all these different surfaces, whether it's a phone screen or a car screen, a developer only needs to implement the necessary APIs or service just once. And when that's done, Android Auto will do all the heavy lifting to ensure a safe and engaging experience across all these scenarios. All right, let's dive into code. So first of all, we need to do a bit of setup because we want Android Auto to be able to find your app. So here in our Android manifest file, I point to a secondary XML file named auto app descriptor. And inside the auto app descriptor, I say that this is an automotive app and it is of the type media. So this really lets us know that your app can provide audio content for auto devices. Once we can find you, you'll need to implement a service. In this case, the media browser service. The media browser service does two things. First of all, it provides a content hierarchy, which is what we use to create a content browser that the user can then use to find and explore audio tracks. At the same time, the media browser should attach a media session, which is what we use to control, or rather remote control, playback inside your app. So here is a sample media browser service. As you can see, we're implementing, or rather extending media browser service compat, which is available in support library 23.2 and higher. And of course, this will help your app run on older devices. There are two methods that we need to implement inside the media browser service. The first one is the onGetRoot method. Now, this is called to retrieve the browser root of your content tree. This root itself is not a media item. However, we use this root to retrieve a list of media items, which are then used to populate the top level of our content menu. Also note that root hints may be passed to you. These can include things like offline, recent, or suggested. And these are really just hints that Android Auto wants to tell you in terms of what kind of content you should be sending back. So try to respect these when you're exposing your content. The second method that you need to override is the onload children call. Now, whenever Android Auto needs to display a list of media content inside of our media app, this method is invoked, and you will be passed a parent ID of the media item, and we expect you to return a list of its children. Now, let's take a closer look at this onload children method. First of all, I want to say, if you are returning media items, try to do so from a cache. And the reason is, you could imagine a user is driving down the highway, they're listening to some songs, and they're going, and they want to play a different playlist. And now suddenly, your app needs to go across the network to download all those songs. And you can imagine, if the cell signal is not great, the user is looking at a screen that's loading, and their eyes are not on the road anymore. So not only is this a bad experience, it's also not very safe. So we really recommend you to cache your media items as you're creating the content tree. So when onload children gets called, you're able to return the media items immediately from memory. Now, if you have to go over the network, just simply detach the result object. Set up your asynchronous tasks, and once you're finished loading, just send it back through the results object. So while we're on the subject of content hierarchies, let's take a look at some of the common pitfalls or mistakes that people tend to make. So in this example here, we have a media app that can play radio. And it separates it down into local radio and further breaks it down into different genres like jazz or pop or other types of music. In this case, the user has to click at least 3 times before they can reach the first playable item. So this deep nesting is actually not very good, because you can imagine, again, the user's on the road, and they're tapping the screen 3 times before they can do anything. So again, in this case, you should really try to surface interesting content or engaging content higher up in the tree so that it's available to the user right away. The next thing is, we've heard a lot of feedback from our users that they want to be able to get to all of their media content while they're inside the car. So we're working on ways for users to browse through large amounts of media content, of course, in a safe manner. So what does this mean for the app developers? What this means is, you should not truncate your content trees prematurely. In this example, the user has finally gotten to the jazz section, and there's actually just 2 stations because everything else got cut off. So let's try not to do that. So the last thing I want to talk about content browsing, it's if your data is dynamic. So for example, you're a media app that generates a playlist based on where the user is or the traffic conditions. Then when that content changes, you need to notify us because we can update the content browser for the user. And you would do this through the notify children change call. All right. Now that we've talked about media browsing, let's take a look at media session. So the media session serves 2 purposes. First, it lets you send updates to us about playback states or metadata changes. Also, it allows us to remote control playback inside your media app. So here we have our media browser service again. This time, let's take a look at the onCreate method. Inside of onCreate, we instantiate a media session object. And the first thing that we do is we take its session token, and we set it as the session token for the media browser service. Now, this is important because when Android Auto connects to your media app, the first thing it does is it retrieves this session token and creates a media controller object, which is then used to control playback and receive updates. Also, there is the media session callback, which we use to handle a playback event, which you will implement to handle playback events from Android Auto. We'll take a closer look at this in the next slide. And finally, remember, when everything is done, release the media session. This frees up any system resources and actually tells Android Auto that you're finished playing, so we can clean up any leftover UI elements. All right, so here's our sample media session callback. So the methods here allow the callback object to handle various playback events. You overwrite them as you need. So for example, if your app is a streaming radio app, then maybe you don't need the on skip to next button because that doesn't make any sense. So in that case, you can simply leave that as the default implementation. Now, in the case of a on play or on resume, you should check if your media session is active. If your media session is not active, set it to active, and this tells Android Auto that you're in fact playing and that we can surface your content inside of our stream or inside of our notification area. Another method we want to talk about here is the onPlay from media ID. So this method is invoked when a user goes through the content browser, clicks a playable media item, and they expect something to play. This method will be invoked, and the media ID will pass in. And this media ID is the same that you have passed to us through the media item in the onload children call. So you can imagine the media ID should be unique, and it should be persisted, so you can find the right song to play when the user clicks on it. A note about voice support. So if you want your app to support a command through voice, like play jazz on my media app, you'll first need to specify an intent filter inside your manifest file. This basically tells us that you are able to handle playback from search. So when the user issues the actual command, we'll launch your app, and the onPlay from search call will be invoked. Now, you will be passed both a query and a set of extras. So if the query, first of all, is empty, you should still try to play something back, because this tells the user that your app is responsive and that their action has taken place. Now, if the query is valid, you can try to parse the query yourself, or you can look inside the extras, and we'll pass you information such as title, album, or artist name. And finally, if you can't actually find the song, that's OK. Just show an error. Again, this is to tell the user that your app is responsive. So now let's look at some of the updates that your apps can send over to Android Auto. First of all, there's the metadata object. This contains things like title, artist, or album art. And let's focus a little on album art here. As you saw earlier in the demo, the album art of the track that's playing can show up as the background image of maybe a 15-inch 4K screen. In this case, resolution is really important. So you can send us that album art in 2 ways. You can send it to us either through a bitmap or a URI. I recommend you guys to do it in a URI because Android, the framework, actually scales down the bitmap to 320 by 320 dp. So if you want a high resolution image, the URI is the way to go. So the other state that you can send us is the playback state. This tells us things like if your app is playing, if it's stopped, and actions that it can take, if it can skip forward, if it can pause. It also tells us the playback position, how far along in the song you're currently playing. A couple of tips here. Don't send us a playback state change every second if the only thing that is changing is the playback position, because we don't use this value to update the progress bar inside of our media app. In fact, you're just taxing the system, and we're ignoring these updates. On a similar note, if your app is actually stopped, don't send playback states unless they're actually changing, because again, we're just ignoring them, and you're taxing the system. Finally, I want to talk about the buffering state. This is an interesting one, because when the user clicks play and you need to download the song, you should send the state to us right away, because we can then tell the user through a spinner or a progress bar that the track is being downloaded. Because if you don't do that, your UI will seem somewhat unresponsive. And with that, I'll hand it over to Vincent for customizations.
Thanks, Victor. Hi, everyone. My name is Vincent, and I'm an engineer manager on the Android Auto team. So with Android Auto, we want media apps to be able to showcase the uniqueness their users have grown to love and expect in the car. It's also important that the user experience is one that is optimized and friendly for driving. And to be honest, this is a challenging task. Android Auto itself has undergone extensive user studies, driver distraction testing in simulators and in real-life driving scenarios where minimum contrast ratio, tap target sizes, glance times, cognitive load, and driving performance are all factored into its design. As you can imagine, this isn't something that we want or we think every media app should have to get right. In the end, we thought that it was best for the users and developers to have an API that abstracts this out so developers like you can focus on making your apps great, knowing Android Auto will provide an appropriate in-car user experience. So in this section, I'll be walking you through how you can easily customize your media app for Android Auto. So media playback controls are the primary interface for users to control their media playback experience. These controls are displayed throughout Android Auto and laid out differently depending on the surface and the condition that Android Auto is running in. For example, the audio controls card on the phone screen might look different than the audio control cards on the car screen. And it also looks different in night mode versus in day mode. Again, this isn't something that your app needs to be concerned about, since Android Auto will handle this behind the scenes. So how do you get your app to surface the appropriate actions or the controls for your app? In the media session playback state, remember that your app is actually already updating the playback state for the media session. Set the supported actions via the setActions method in the playback state builder. The playback state compact class, if you look into it, has a defined set of standard media action constants, like play, pause, skip forward, and skip previous. Let's look at the action skip to next constant as an example. Because it's listed as a supported action, Android Auto will surface the button in the controls panel. When the user interacts with this button, the media session's callback on skip to next API will get invoked. A few things to keep in mind. Remember to always keep the supported actions up to date based on the appropriate playback state that the user may be in. For example, if the user is at the beginning of the playlist, it might be a good idea to remove the skip to previous action. We also recommend that apps always report all the supported actions so that the app doesn't lose any functionality. Now, what if your media app supports additional actions that aren't defined in the playback state compact? For example, maybe a thumbs up. Well, you can create your own custom action. A custom action contains a few things. An action string. This is very specific to your app, and it's unique for each custom action. An action label text. This may be displayed for accessibility. A drawable resource. This is shown in the actual playback control. Remember to include transparency in it, and we also recommend using SVG so that we can properly display it in various screen sizes. And lastly, there's also an extras bundle that is optional. So when the user interacts with the custom action playback control, the onCustomAction method of your media session callback gets invoked. This is where you can handle the actual like action. We also know product branding is important for you, and we want your app's branding to show through well in Android Auto. So if your app already uses the material design color theme, like the color primary, color accent, and color primary dark, Android Auto will show these colors in the appropriate places throughout our UI. You can also define an Android Auto specific theme in your media app by adding a metadata element in your app's manifest, as shown. Lastly, Android Auto may show a media-related notification. For example, when the next track is being played, a notification with the track name will be shown. So be sure to specify an icon resource in your manifest so that your app's icon is also displayed in the notification. So that's it. With a few simple steps, you can customize your media app with an Android Auto that works across all the supported surfaces, while getting a driver-tested user experience for free. So next, I want to talk about messaging. We know that staying connected to people that we care about, like our friends or family, is very important to all of us, regardless of whether we're in the car or not. With driver safety in mind, it's important that users can access their messages in Android Auto with minimum distractions so drivers can focus on the road. We don't think every messaging app should be burdened with having to do extensive driver distraction testing to achieve this goal. So with messaging, we've taken a similar approach as we have with media. We have an API that abstracts out these things so that you don't have to worry about and focus on getting the messaging experience right. This is just a recap of how messaging works. As Paco demoed earlier, it's pretty straightforward. We have a notification that appears when it comes, and then there's a messaging card that remains in the overview screen. The API is quite simple. It's actually built on top of Android notifications, which is something I'm sure your app is already using. So when an incoming message arrives, your messaging app already will notify Android of the notification. Now, if your notification is extended with Car Extender, Android Auto will be able to receive the notification and display the notification to the user. When the user issues a read command via voice, a read pending intent gets sent back to your app. Similarly, when the user replies to a conversation, a reply pending intent gets sent back. Like media, before you get Android Auto to recognize your app for messaging, make sure you include the notification usage in your Android manifest. OK, so let's dive into the part of extending your notification with Car Extender. The first portion of this code snippet looks familiar. The interesting part that we care about here is where we extend it with a Car Extender object. One tip that I want to pass on is if your app is actually checking to see if Android Auto is present before extending the notification, we recommend not checking for the existence of the Android Auto package, since that's not very reliable. Instead, you can use the UI mode manager and see if Android Auto is running in car mode. So let's look at the unread conversation object. First, I think it would be useful to define some definitions. So a message is essentially just a short length of text that allows Android Auto, that Android Auto will read out to the user. It's best to not make these messages too long. A conversation essentially is a collection of messages that are grouped together in some way. And typically, messages between user and another person will be a conversation. So with that, an unread conversation is essentially just a set of unread messages for a particular conversation. OK, so what goes inside this conversation, this unread conversation? You can pass in the conversation name. This is the text that gets presented to the user when Android Auto presents an unread message. Obviously, you pass in the actual messages. There might be more than one. And in this case, when you set the timestamp for these messages, include the timestamp for the most recent message. And there are two remaining ones, the read pending intent and the reply action that we'll dive into more in the next slides. Also, if there's a message that only has an image, we recommend including a readable alt text so that the user doesn't experience a broken experience when reading back the messages. Also, please do think about how this works for group chats. We recommend actually just testing out the flow and seeing if, when the user is reading back the message, if it's a good user experience. All right. OK, so the read pending intent, again, is a pending intent that Android Auto sends back to your messaging app when the user has invoked a read action. Creating the read pending intent is pretty simple. You create the intent that you want Android Auto to send back when the user has completed a read message. The primary things to highlight is you just want to set the action string that is specific to this read action. Be sure to set the component because we want this intent to be explicit. This way, it's guaranteed that your app will get the pending intent. And then lastly, put the extra put the conversation ID as an extra in the intent that you can later check. And once you have that, then you can just wrap it in a pending intent. So receiving this read pending intent is pretty simple. In your app's manifest, just have a receiver that is registered against the read message action string that we defined earlier. And this way, when the read pending intent is sent back to your app, the appropriate receiver, the appropriate broadcast receiver is invoked. And in the onReceive callback, this is where you can process the intent and handle the read message and event. So the last part is the reply action. I'll kind of just glance over this. Again, this is sent when there's a reply event. Similar to the read pending intent, you create an intent with the appropriate action string that is specific for the reply message. And then you can wrap the intent with the pending intent. The remote input object is just passed along with the pending intent that gets sent back to your app, which will store the actual string making up of the user's reply message. And with that, the broadcast receiver that you've registered will get the onReceive callback, and then you can extract the ID and then the message reply. One hint or one tip is when you get this, just don't assume that the user has read any unread messages, since the user can actually send replies out of band. And then, like media, you can also customize the look and feel in this notification, the car extender object. Again, that was a simple way of making your messaging app support Android Auto. And next, I'm going to invite Paco back.
All right. Thank you, Vincent. Just wanted to conclude summarizing what I believe are the main three takeaways of the presentation. The first one is that Android is showing great momentum in the number of cars that are supporting Android Auto, the number of applications that are already running on the platform, and also the number of countries where it's already available. The second one is that we're expanding our original platform to give your applications significantly more reach by enabling Android Auto on your phone screen, and of course, bringing the power of Android N natively into the car. And the last point, still, the same interfaces will work across all three surfaces. Your application will run in a framework that is being tested for driver distraction, to minimize driver distraction, including voice integration to power the most common tasks that you can perform. As for next steps, if you are ready to start implementing, to start integrating with the platform, all the technical details that we talked about today are available in these links. Please join the developer group, Android Auto Dev. And if you remember any link out of this talk, developerandroid.com/auto. In the meantime, if you want to learn more, you have questions, come talk to us. The sandbox is right behind the big tent here. And check out the cars from our partners. Check out the concept car and all of the other ones. We also have phones there so you can see how this works. If you have time and want to give coding a try, we also have an Android Auto specific code lab in the code lab section. If you want to hear from us in the future, sign up for news at android.com/auto. And I don't think we have time for QA, but again, come talk to us. We're in the sandbox. And I don't want to really take any more time of yours. Please, it's been a long day. Go enjoy the concert. Go relax. And thank you very much.